Check your understanding for 3.1.1b, which deals with simplifying fractions using the GCF, or the greatest common factor. So let's take a look at our fraction 30 over 63. The first step is doing factor trees for both of the numbers in our fraction. If a number is even, I like to start with 2. So 2 times 15 is equal to 30. I circle my prime number. 3 times 5 is equal to 15, which are both prime numbers, so I'll circle them. Then I'm going to move on to 63, and I know that 7 times 9 is 63. 7 is a prime factor, so I'm going to circle it. 3 times 3 is equal to 9, which are both prime factors. The next step is to rewrite our fraction as a multiplication sentence using our prime factors. So 2 times 3 times 5, and then 63 would be 3 times 3 times 7. The next step is to find our giant ones, which is 3 over 3, and then rewrite it, putting our giant one all together. If we had multiple giant ones, we would multiply those together, but we just have one. And then we're left with these two fractions. And what we're going to do is actually multiply, oops, not a 3, a 2, multiply those back together, which would give us 3 over 3 multiplied by 10 and 21. So what is left over outside of our giant one is our simplified version of the fraction. So 30, 60 thirds. The simplest form is 10 21sts. Moving on to our next one, 56 over 98. We're going to do our factor tree for 56 and 98. 56 is an even number, so I'm going to start with 2. And I know that 50 divided by 2 is 25, and then I'm going to divide the 6 by 2, which is 3. So we're left with 28. And 28 is another even number, so we'll do 2 times 14, and then 2 times 7, which are both prime numbers. Then moving on to 98, another even number. So we have 2 times, I know 90 divided by 2 is 45, and then I have 8 more, which is 4, so 49. 2 is a prime number, and then I know 49 is 7 times 7, which are both prime numbers, so I'll circle them. Next step, to rewrite our fraction as a multiplication sentence of the prime factors. So 56 is 2 times 2 times 2 times 7. And then 98 is 2 times 7 times 7. And when I'm looking here, I know I'm going to be making giant ones, so I'm looking to see where I can line up some fractions or factors to create those giant ones. So I'm going to line up my 7 and my 2's. Then, like I said, the next step is to find your giant one. So we have a 2 and we have a 7. We'll rewrite those fractions combining our giant ones, which would look something like this. 2 times 7 is 14. And then we'll put the rest of our factors here. And then We would multiply those together to get our top number, which is 4 over 7. So our simplified version of 56 over 98 is 4/7. All right, our final problem, 26 over 39. We'll start by doing our factor trees. This is an even number, so I'm going to start with 2, and 2 times 13 is 26, and both of these are prime numbers, so I get a stop. Then here, this is not an even number, but I see that this back number is divisible by 3. So I'll do 3 times 13, which again, those are both prime numbers. Then we're going to rewrite our fraction as multiplication sentence of our prime numbers. So 2 times 13 and 3 times 13. Look for our giant ones, which are 13. And we're left with 2/3, which is our reduced fraction, our simplified form. So 26/39 in simplified form would be 2/3. The back side, the top portion, is going to be dealing with this dot pattern up here. In your mild, you figured out what figure 3 would look like and what figure 5 would look like. And then in the medium, we actually ended up doing our equation, which is our first question for our spicy. So let's just go back over how we got that equation. So I know when I'm figuring out equations, I want to go back to figure 0 to kind of see if I have a starting number, which is 2. So I know if I'm solving for n, I'm going to have a starting number of 2. And then I'm going to be adding on what's left here. I know I'm adding a set of 2 every time, and then I'm adding a 1 set of 2. Here I'm adding, again, sets of 2, and then I'm adding the figure number amount set of 2. So 2 sets of 2. Here I'm adding sets of 2, but I'm adding 3 sets of 3. So how we would show that in here is 2 in each set of the figure number n. So our equation to figure out any figure number amount of dots would be 2, which is our base number, plus 2 times whatever the figure number is. Now down here, is there any figure that has exactly 38 dots? So we kind of go back here and we say, okay, we have 38 dots. I know that figure 0 would start with 2 dots. So I'm going to kind of subtract 2, and then I'm left with 36. And then I know that each figure number would have 2 dots. So I would divide that by 2. So here I'm adding 2. Here I'm subtracting 2. Here I'm multiplying by 2. Here I'm dividing by 2. And 36 divided by 2 is equal to 18. So what we can do is we can check, is figure 18 the one with 36 dots, by putting 18 back into my equation, which would be 2 plus 2 times 18, 2 plus 36, and 38. So we are good. So the 18th figure would have 38 dots. If 5 notebooks cost $5.25, how much would 3 notebooks cost? So we know we're starting with 5 notebooks. We know all of those together cost $5.25. So I can kind of set up my fraction as I have for all of my notebooks, it's $5. And I have 5 notebooks for that. But what we want to know is 3 notebooks. So one way to go about doing that is to find out what one notebook costs, or what we've been talking about, that unit rate. And how I do that is I set this up as a division problem. So $5.25 divided by 5. 5 goes into 5 one time. I bring up my decimal. 5 doesn't go into 2, but it will go into 25 5 times. So each notebook costs $1.25, and I want 3 of those. So I would multiply that by 3. It's 15. 3. So 3 notebooks would cost $3.15. Finally, the bottom. You have to complete the previous problems in order to solve this one. So what we talked about in the mild is we set up our area or our perimeter around the soccer field. One lap was 390 yards. Then we figured out that if Stacy does that perimeter walk 4 times each day, her daily walking would be 1560 yards. And if she exercised 3 times a week, she is walking 4,680 yards. Now we're going over here. A mile is 1,760 yards. And we want to know how many miles does Stacy walk each week. So what we'll do is we will take our yards, 4,680 yards, and we want to divide that by how many yards are in a mile. And I'm actually going to set it up like this because it's a little bit easier. And this is our dreaded long division. Not dreaded, just takes a long time. So I would ask myself, how many times can 1,760 go into 4,680? And here's where we start to just kind of guess and check. So I know that 17,000 is pretty close to 2,000. And what I know about 2 and 4 is that 2 goes into 4 2 times. So I'm going to start with a guess of 1760 going into that 4,682 times. So I'm going to figure out what that would be equal to. Okay. So I ended up with 3520. And if I add one or more of these, I will have gone over this, so I am good. So what I'll do is this 2 goes right here. I'm actually going to erase this yards because we're going to want to add on. And then I'm going to subtract Okay, and I can double check, can I put any more of this into that? Nope. Now, because this is a remainder and we don't want a remainder, we are going to add on zeros to figure them out and continue going. So I have now 11,600, and I'm asking myself, how many times can 1760 go into that? I know this, again, just guessing, this is close to 2,000. This is close to 12. So I'd ask myself, maybe how many times does 2 go into 12? And that's 6. So I will start my guess and check at 6. Okay, and that looks pretty close. If I add one more of these, it will go over. So this is 6, and then I'm going to subtract 0. That's a 5, 4, 0, 1. Then again, we can add a 0 down and bring it, and I'm left with 10,400, which is really close to that again. And so I know that it's about this. And I know I'm going to have a little bit of a remainder, but she walks about 2.66 miles.